classic experiment design. Why do we want to talk about classic experiment design? Because microgravity experiment design is a really simple outgrowth of classic experiment design. So I think we all should start with an understanding of classic experiment design. How do you design experiments in general? So let's do that right now. So the first thing to say is when you are an explorer, remember I said before that it all starts with you looking around your world, opening yourself up to your innate curiosity and daring to ask a question. And so you look around your world and you see something interesting and you say, wow, that's really cool. Why or what or how? And that starts a personal journey of exploration. It also defines a problem to be solved. And when we're talking about defining a problem to be solved, that question can be thought of as the essential question for that experiment, okay? Now, you might look around your world and you might see something biological, physical, or chemical. And so, okay, cool. Let me give you a very simple example of something biological. I want to see how these seeds germinate. And by the way, we're now moving into an audience participation situation, which means that everybody who does not have ambient background noise, please unmute right now because you're in Dr. Jeff's class. And anybody who is just a disembodied name on the screen who has the ability to put on their video, now is the time because I want to see you. Okay, this is not how we do classes with disembodied names on a little card sitting at a desk. Okay, so I look around my world, I see something interesting. I'm giving you an example of something biological. I want to see how these seeds germinate. Is it enough to just have the seeds or do I need more stuff?
More.
What do I need?
You need to moist the seeds.
I need to what?
Moist it with water.
Okay, so I need water. What else?
Oil.
Soil.
Soil.
Nutrients.
Nutrients. Okay, so I'm taking what you just told me because I want you to help me tell this whole story, okay? You're telling me that I might need water and a growth medium with a certain composition, which includes nutrients, probably need an atmosphere with a certain composition, probably need a certain temperature. If I want to see what happens beyond germination, I might need a light source with an amplitude distribution, a frequency distribution. And so what you're telling me is that when I'm studying these seeds, I need to study them in an environment. And that environment has a slew of characteristics associated with it. Is it true no matter what I want to study, whether it's physical, chemical, or biological, I will need to study in an environment? Sure. Will it have lots of characteristics? Yeah, I see everybody shaking their head. Yeah, sure. And so as soon as we understand whatever I'm studying is going to be studied in an environment, we have to add the word, we don't have to, but we do, we add the word system to it. So we're studying a biological system, a physical system, or a chemical system. Now, how do we study this thing we want to study? What do we do in classic experiment design?
Make a question.
What?
Make a hypothesis, like a question.
Yeah, so we start with the question. I want to understand how these seeds germinate, right? And so want to study how these seeds germinate. And so my question to you is, how do we do that?
You need a control variable.
Oh, you use the word variable. What do you mean by that?
Oh, a control variable.
No, but let's just concentrate on the word variable. What do you mean by that?
Like something to compare it to. It could be anything.
Well, you're talking about the control. But what I'm asking is, what does the word variable mean?
A variable
you
is
can also
something
So it's something that you can alter, right? You can change. That's why it's called variable. And Isn't it true that all of the characteristics in an environment could be thought of as variables? So if I want to understand how seeds germinate, I want to change the variables and see what happens. I want to see the role of the variables on what I'm studying. That's how I study it. Does everybody understand what I'm saying here? Give me a thumbs up if you do, right? If I want to understand how seeds germinate, I can change the variables in my environment and see what happens so we can understand the role of these variables on what I'm studying. I can understand how this works. Would I change all the variables at once? Why not? Jade, why not?
Then you don't know what is affecting what.
Exactly, because if you change all the variables at once and you see a behavioral change, you have no idea what variable caused that behavioral change. Everybody with me on that? Give me a thumbs up if you're with me on that. Okay, so what do we do?
Have multiple versions.
Well, in classic experiment design, what do we try to do with the variables?
Keep them all controlled except for one.
So what, April?
You can call me April.
April.
Like the month.
Okay, good.
Yes.
Okay. So what April is saying is in classic experiment design, we try to keep all the variables constant except one, if at all possible. What do we call that variable we're changing? The one that we're going to change?
Independent.
The independent variable. And here's a really cool question, okay? Here's a really cool question. Of all the variables that are in this environment, how do we figure out which is the one we want to change?
By testing it?
Well, testing what? Testing all of them? 1,000 variables, maybe?
Depending on what your desired outcome is.
It what?
It depends on what your desired outcome is.
Oh, okay. He said it depends on what your desired outcome is, but if you're doing science, I don't know what a desired outcome is. That's kind of a big bias, don't you think? Right? So can you rephrase that? Was that Kenneth?
Yes.
So rephrase what you just said.
You gain information based off of an experiment and the variables that you.
Okay, this is good. Your thinking caps are on. That's good. Okay. So again, let me ask, of all the variables we have in this environment, how do we figure out which is the one we want to change? That's kind of a really important foundational question for all experiment design, which often we don't ask ourselves. Anybody? I see puzzled looks. Okay, I will give you the answer. It comes from the original question you asked. Typically, the original question, the essential question that defines the experiment to be done, screams what the independent variable should be. So let me give you a concept. So is that sinking in? Give me a thumbs up if you think that's sinking in, at least conceptually. Okay. So now let me give you a concrete example. The Acme Seed Company that brings you Roadrunner and Wile E. Coyote have branched off into genetic engineering. It is the 21st century. And they've created a genetically engineered species of wheat that they claim grows really well in dry climates, which means that they can bring food production to areas of the earth that see famine. It's a genetically engineered species of wheat, and the claim is it grows really well in dry climates. But I don't know if they're telling me the truth. So I want to put that claim to the test. So I will rephrase their claim as an essential question. Does this genetically engineered species of wheat grow really well in dry climates? You tell me what the independent variable is that we have to change.
Level of moisture in its environment.
The amount of moisture in the environment, the amount of water that you provide the genetically engineered species of wheat. So now who was talking about the control variable? Who was that again?
I think it was Sammy, I think.
Oh, I think it might have been me, Grace.
Grace. Okay, Grace. So hold this thought. Okay. So here's the deal. I'm going to give you a visual for a plot, a graph that we're going to make. Okay. So what we're going to do is we're going to look at food production on the vertical axis, and we're going to look at the amount of water we provide the genetically engineered species of wheat on the x-axis. So what we want to do is we want to understand what food production looks like with little water, and what food production looks like with more water and more water and more water. And we see how food production depends on water. And what we want to show, okay, focus on this. What we want to show is you get high food production or good food production with less water. You get good food production with less water. But everybody with me on that? But how do we figure out if we get good food production with less water? Grace, this is your point of entry.
I'm put on the spot a little bit, but depending on the graph, you want points, a lot of points where there's high food production with low water amounts.
But how do we know that that food production is good enough? How do we put the claim to the test? How do we know that with less water, it's just average? What we get for food production is just average food production.
So you can compare it to different types with the controls.
Okay, Grace, see, this is good. We're a team, Grace. We didn't rehearse this beforehand, right?
No, sir.
Okay, all right. So the idea is that you have to compare this unknown life form, right? This life form never existed on Earth before. It's genetically engineered. You have to compare its behavior to known wheat that might have been grown for thousands of years. And Grace, what do we call the experiment with the known wheat?
I think it would be the control.
The control, right? You need to control. So here's the deal, okay? What we want to show when we do the graph, the plots for both of these wheat variants, right? The known wheat that's been around a long time and the genetically engineered species of wheat. What we want to show is that for the same amount of water, low quantities of water, we get more food production with the genetically engineered species of wheat than we do with the regular wheat. Let me say it again. What we want to show is there is a regime in the low water area, the low water regime, where with the same amount of low water, you get better food production with the genetically engineered species of wheat than you do with the classic known wheat. Does everybody understand what I just said? Give me a thumbs up if you do. If you want me to say it again, just let me know. Everybody good? Okay, cool. So let me kind of summarize what we just did, right? What I said in classic experiment design is you have to be open up to your innate curiosity. You have to look around your world. You have to dare to ask the gift of a question. You look around, you say, wow, that's cool. Why or what or how? And now you've defined through that essential question an experiment to be performed. And you might want to hypothesize what you think will happen based on that question, or you might not. And so the point then is that whenever you're studying something, whether it's physical, chemical, or biological, it's going to be studied in an environment with a whole bunch of characteristics. And we can change the word characteristic into the more sciencey word called variables because we can vary them. And we want to vary variables in general because we want to understand the role of the variables on what we're studying. That's how we learn about what we're studying. But we don't want to change all the variables at once because then we have no idea what the behavioral change is due to. We don't know what the variable was that the variable or variables were that caused this behavioral change. So in classic experiment design, you try to keep all of the variables constant except one, if possible. We call that the independent variable. And typically the original question that you're asking of what you're interested in will scream out what the independent variable is. And I gave you an example of the germinating wheat, the genetically engineered species of wheat. And working with Grace as a team, we found out that you've got to compare it to regular wheat, classic wheat. We call that the control experiment, and it allows comparison of the unknown to the known. Everybody with me on that? All good? Okay, so now what I'm going to do, any questions, by the way, at all?